This is GIS-based tools for prioritizing pipe repairs. I'm Erin Nelson from Altaterra Consulting. And
Meiring Borcherds, city of Mukilteo.
yeah, so we'll get started. Okay, so what we're going to be talking about today is how you can use GIS to assess and evaluate pipe risk. As we all know, pipes are underground. We don't look at them very often. So you can use GIS to figure out which pipes you want to look at, and then how you can go about assessing the condition of your system. So also, we're going to be talking about developing GIS-based tool for tracking your pipe condition assessment program once you do get something going, and the cleaning status data. And then once you have all of that data, evaluating the risk and prioritizing repairs. Okay, first of all, we should talk about what we're talking about for a definition of risk. So what we're talking about is the chance that something bad will happen and there's going to be negative consequences. So this cartoon here, we all know, most of us know, Wile E. Coyote. Something bad always happens to him. So the chances of him, getting in a bad situation is 100%. So he's always in the negative consequences are going to always be there. So what about stormwater pipes? So what we're looking at is what the consequences of the failure are going to be if something happens, and the likelihood that something is going to happen. So I guess you could look at it as we all live in an area where there's earthquakes. So there's a likelihood there's going to be an earthquake. But what are the consequences of that earthquake going to be if it happens in our neighborhood? Is it going to be really bad if we have a certain type of house? Is it going to be, it can be worse in different situations of where we live. So what we did in this analysis was we first used GIS to just identify potential consequences of failure. So we looked at the geography and pipe characteristics to see what would be the factors that would make a pipe failure worse. So some of the things that we looked at, this is a symbol of a road. So for instance, if a pipe was adjacent to an arterial versus a residential road, the consequence of that pipe failing would be much worse. So looking at, okay, like what's going to happen if you have critical areas nearby? Is it going to affect, wetlands? What about critical facilities you have? If you have a pipe that fails like near a hospital and you've blocked access for, emergency vehicles, landslides. We also looked at the size of the pipe as a proxy for how much flow might be in there. So if there's, if it's carrying a lot of water, then you might have a bigger impact. So then we took those and then weighted the factors based on like different road types, how close the pipe might be to different critical facilities, and applied weighting factors to those. And then we just conducted an analysis of all of the pipes in the city and applied numerical scores to what would those consequences be, and sorted the pipes then based into high, medium, and low consequences of failure. And so an example is that we have this pipe C up here, and it's near a stormwater facility. It's near a fire station. So that's one example here. And then you have a pipe here, and it's a smaller pipe. And then you have this large pipe that's by a wetland, a landslide hazard area. So pipe C, though, had a higher consequence of failure than pipe B in these Mukilteo examples. And the landslide hazard areas are up there too. And I think that this one was because of the landslide hazard risk and then the fire station. So because of the weighting factors. So the end result was we had a map of all of the pipes, high, medium, and low. How many pipes. We did a jinx analysis with natural breaks for, to sort them into groups of how many would be high, medium, and low based on their scoring. So on the other side of things, what you were just talking about is that Mukilteo has a pipe inspection program, a CCTV condition program that they're doing. And they are inspecting all of their pipes over a certain size, starting with the north end of the city. So up here, the north zone, central zone, and south zone. And they're cleaning the pipes, the city's cleaning the pipes, and then the contractors inspecting the pipes. So they've already started with the north zone, and they've almost completed that. And then they're looking for funding, for grant funding to start with the central zone and then following with the south zone. The consultant's reviewing the videos and assessing the types of repairs. So once they get that condition data, then they know what the likelihood of failure is. So they have that second piece of risk. So for the likelihood of failure evaluation, first of all, a custom tool that was customized using just the basic ARC collector tool to track the pipe cleaning, the inspection, maintenance, and also this was really important, that GIS data revisions, because when you're doing a condition or a pipe inspection program, you'll find that when you're cleaning or you're inspecting pipes, you'll find that there's pipes that are out there that aren't in GIS. They're in the wrong locations. They're not accurately mapped. They're a different material, they're a different size, different lengths. So making sure that you get those data revisions while you're noting them is really important. And so we built that into the collector app so that it was real-time feeding back into GIS so that they could make those changes. So we use those scores then to assess the likelihood of failure. Again, high, medium, or low. And now Meiring is going to talk about how the data is being used in the city. So.
Thanks, Erin. So this here is a screenshot of the dashboard that we have. This dashboard is updated every week. So on Thursdays, the contractor would come in and give us the hard drive with all the video data that they collected during the week, and then GIS would QIQC it, and then they would upload it to our server. That would all then be kept in separate files per week. At the end of the year, we then gave it to a third party, a consultant, who would go through it and help us with our risk assessment into high, medium, and low for us to focus on what to get to next. So on here, you'll see that the bottom, the green is the ready to clean. So our service crew goes through. For this grant, we did a light cleaning. So one pass with a jet vac was part of the grant. So they would tell us what is ready, and it would show up on the map of what is ready. These just show for the last 2 years. So this started in 2021. This year is the last year for the northern part of the city. So you can see here, some of it couldn't be cleaned because there were blockages, pipes may be broken, or the camera just couldn't get down there because there was a cross connection from someone's downspout into the MS4. So these are just the ones that couldn't be cleaned. And these we're going to come back to at a later stage then to maybe do more heavy cleaning or so forth and so forth. And then up to now, we've done 13.6 miles of the first 23 miles in the northern zone. So this was a really great tool that was developed by the GIS folks for us to, because we have 3 different groups of people working on this, for them to be able to communicate with each other. And then the red, that's what's getting done in 2023, and we should start mid-May, depending on when the rain stops, right? So, but hopefully we'll start in May and do the last 10 miles for 2023. So as Erin said, there was the the two failures, the consequence of failure. So with the consequence of failure, the map you saw that had the red, green, and yellow lines on them. So out of that, we found that there was 444 pipes that was high consequence of failure, 1,600 was medium, and 2,800 was low. Then we went over to the likelihood of failure, where we have low, medium, and high. So we would compare those with each other as we go through the inspections. And so as of now, for the last 2 years or 13.6 miles of surveying we've done, or CCTV work we've done, we've identified 7 of the highest. So those are the ones that's failing that we have to get to as soon as possible because they have major issues and they have a high consequence. So if they would fail, they would disrupt major traffic or access to critical facilities or critical areas. So the general strategy for the prioritization of the pipes were to address the high-risk pipes first, so those 7. So those are out with the crew to either get to a fix, or we have to, some of them we have to contract out because they're too complicated to fix for us because they might be on 525. So they need to be fixed there. The medium, we're going to be monitoring those. So we'll keep looking at those. There was like 56 of those. Spot check those, and then the ones that were negligible, so very low, those we will just come back to in a few years' time again. So this way, out of the 75 miles of pipes we have a better understanding of what our prioritization needs to be in our budgeting for fixing those things. So just quickly, a couple of lessons learned through the last 3 years is to reduce handoffs. So because there's all these different columns of people, silos of people that's working on the same project, you have the manager, the city crew that does the cleaning, then you have the contractor that does the CCTV work, and then you have a contractor that does the risk assessment. So being really clear with the handoffs of when you hand off to whom, and so that that person knows what they need to do. And with the Great Resignation we we also found that it's also smart to have standard operating procedures. So SOPs written for each one of those processes, so that if you have staff changing over or anything else that happens, that the next person that comes on can just pick up the project and move forward instead of having to figure out what the predecessor did. So that was very important. And we've actually done that with all our processes in the Stormwater department now. So everything we've done, I had the staff do SOPs for everything they do. So it's easier to hand off work to the next person. Then have a clear expectations from the team. Make sure that each team member and each one of those teams know exactly what you want them to do, when you want them to do. And through that is just good communication, and clear direction. Then make sure that the CCTV crew knows exactly what data you need to collect for the next consultant, because the next consultant wants specific data to do the assessment of the risk. So what we have found is that they looked at some things sometimes, but they didn't add it to the data sheet. And then it makes it hard for the next consultant to actually do the review and do the risk assessment. So make sure everybody knows exactly what the next group needs. Then evaluate your GIS infrastructure. So what we learned here is we didn't have enterprise. We just had our Esri license, but we didn't have enterprise system. So we learned that we needed to get that so that all the different maps and folks can talk to each other much more easily. And through that, we got counsel to get us enterprise this year so we can have a much more clear and more successful GIS program. Then need more cleaning for the vectors. So what we did is we had our own vector truck, but during this in May and June, we actually rent a second vector truck so we can stay ahead of the CCTV crew. But what happens is that you need to, when you take your vector truck to the decan facility, you need to clean it out. And we actually had a bottleneck because we didn't have enough water to clean the one truck. So they kind of bottlenecked at the decan facility. So we had to add some more water to the decan facility to clean the trucks before they go out and just better plan that process. And we also learned that our decan facility wasn't big enough. So we actually got another grant from DOE and was able to construct a $1 million decan facility to keep doing this work in the last 2 years. Other things that we learned is the focus. Helped us focus on ownership of infrastructure, because there's private pipes and MS4 pipes. It forced us to go through our GIS system, go through all our infrastructure, and really figure out who owns what, because we didn't want to spend our time in investigating, cameraing, and evaluating the private system. So this forced us to actually look at who owns what. Is there easements also? Because we found a lot of our MS4 is running across private property with no easement on it. So all those things came out of this program, and now we can fix those and move forward and make the program run better in perpetuity. And then also this helped us look, the other part of this grant that they wanted us to do is to look for illicit discharges. So look at the tap-ins into the MS4, make sure that they are not illicit discharges coming into our system. And the other reason why we got the grant from DOE is because we were removing legacy sediment. So sediment that's been in the pipe for decades, sediment that is laced with copper and other pollutants, petroleum products. So we are now removing all that legacy sediment out of the system so it doesn't get flushed into our receiving waters. And then thirdly, we identified quite a few utilities that accessed our utility. So they did directional boring through our system. So this CCTV program actually helped us identify some of the infrastructure that was broken, or some gas lines, water lines, electrical that actually was going through some of our facilities and our storm drains. And we have really good success with working with the other utilities for them to come back and fix those for us. So that was a couple of lessons learned. Just a couple of acknowledgements. Jennifer Adams, who was my predecessor, who started the program with Erin, they did all the great work. I'm actually just picking up the back end of this project. Anne, who's doing our, from Osborne, who's doing our risk assessment analysis for us. At the end, a lot of work, a lot of data that her team has to look at, a lot of video that they have to look at. And then Heather Haskin and John Kidd from EMA, who helped us developing the GIS tool, because that has really been very helpful for us to see what's happening. It's been very easy for me to report back to the Public Works Director and to Council on the progress that we're making too, because it's a pretty picture that shows a lot of data. So it's been really easy for us to report back to Council and to DOE on what we're doing and at what rate we're doing it. And with that, any questions?